Hi, I'm an old guy and I do maths. Today we're looking at how we find the equations of tangents and normals. Now, this usually comes up when you've found the gradient of a curve, such as we have here, and you're asked to find the equation of a tangent and thereafter the equation of a normal. So let's just get some definitions straight. Here is our original curve. In this case, it's y equals x squared. This line down here is a tangent, and it passes through a point that it shares with this curve, just one point. The lines going across this way are normals. They're perpendicular to the tangent, and if you want to see a video specifically on perpendicular lines and how you find them, how you calculate their equations, there's a video in the playlist on linear equations. Anyway, that's a rather busy looking diagram. So I'll just show you how I put it together. This is going to be freehand, so it'll be a little bit rougher looking than that. So here's our original curve, and we have a point on that curve that we want to know the gradient of. And what we do is we differentiate the equation of the curve. So it was x squared, it'll become 2x. And whatever the x value of this point is, we put into this equation and we get a gradient. From that, because we can find, we have the set of points for this, we can find the equation of the tangent. Now, if we were asked to find a normal that passed through that point, that line would look like this. So it would be a straight line, unlike what I've drawn, and it would be at right angles to this. You could also be asked to find a normal that passes through another point. It's the same process. What you have to do is you have to take the gradient of this, which is m, and make it -1 over m. Okay, so that's the rough outline. Let's do one. So, taking y equals x squared as our example, the derivative of that is 2x, and we are asked to find the equation of the tangent at x equals 3. Now, when x equals 3, if we put 3 into this equation, we get 9. 3 squared is 9. Okay, so that's what we're looking for. We're looking for the tangent, the equation of the tangent that passes through this point on this curve. Right, so more pieces of paper. So just to recap, the derivative is 2x. So at x equals 3, the gradient is going to be 6. 2 times 3. That's how you find the gradient using a derivative. Now, what do we know? We know that the equation of the tangent is going to be y equals 6x, this gradient, plus c. And we have some points that, or a point rather, some coordinates that we can substitute into this. So when we do that, we get 9, which is y, equals 6 times 3 plus c. So we can write that as 9 equals 18 plus c. And it doesn't take a great deal of work to calculate that c equals -9. 18 minus 9 equals 9. So the equation of the tangent is this thing here. Y equals 6x minus 9. Now, the normal is the line that does this. So if I just take 2 pens to illustrate, if we say that that's the tangent, the normal is that line. It is at 90 degrees to the tangent. And the first thing that we can say about this is that the gradient is going to be -1 over the gradient of the tangent, -1 over m. Now, you'll recall that the gradient of the tangent is 6, so the equation for the normal will have a gradient of -1 over 6. And this is our general equation, y equals -1 over 6x plus c. We have coordinates, or we have a coordinate, 3, 9, the same one. So this normal is passing through the same point as the tangent, but at 90 degrees to it. So 9 equals -1 over 6 times 3 plus c. A little bit of algebra, and we get c equals 9.5. So we have an equation for the normal, y equals -1 on 6x plus 9.5. Now, if you wanted to, you could take this equation and you could take the equation of the tangent here and you could put them into a simultaneous equation. You could create a simultaneous equation using these two. And the answer would be this set of coordinates, which tells you that you've got it right. Now, the key thing here is the gradient. The tangent of the gradient we'll call m. The tangent of the normal we'll call -1 over m. Sometimes you'll have a fraction here. It's not a big deal. You just follow the rules of division of fractions. Even if it's 3 tall, it all works out. Okay, so where do you see this? First of all, well, usually in high school, somewhere in the applications of differentiation or something like that. But the idea of a normal and, or rather a perpendicular line and another line is something that you will strike in linear equations, again, at high school. Okay, well, I hope that was useful. If it was, please like and subscribe, and I'll see you next time. Bye.